In this video we're going to look at the operation of a cooling tower. So just as a quick overview of what to expect in this video, we're going to look at the operation of this cooling tower here, and we're going to look at how the warm water, which is being sent from the chiller and contains the heat from the building, which needs to be rejected, that's going to enter this header, pass through this spray nozzle and be distributed over this packaging. That warm water will then lose some of its heat as it makes its way to the bottom here. It drip down and then collect into this basin, and the cooler condenser water is then collected from the basin, sent back down to the chiller, where it'll pick up that heat again and be sent up in a continuous loop there. Meanwhile, cooler air is ambient air is being sucked in to this cooling tower. That passes in the opposite direction of the condenser water, and that picks up the heat from the water. But as it does that, it will also pick up some of the water, making this air very humid and very moist. So we've got this drift eliminator at the top here, and that will condense some of that water so we can reclaim it and keep our operating costs down. And that humid air, after it's lost some humidity here, that is then rejected by this fan and pushed out into the atmosphere. We're going to look at each part of this in much more detail, so you can skip through the video if you need to just see a certain part. But let's crack on. Cooling towers are, I've said on a previous video, but these are really used on every single building, large building. Just the type of cooling tower will change. Some will have, some will be kind of open or wet cooling towers, some won't. It all depends on the design criteria. So as you can see on the screen, we've got a little model of a cooling tower which I've made here. And a real world example of one of these types of cooling towers will look something like this. This is the Balti Air Coil Company cooling tower. We're going to run through how one of these works and what it is used for. So in building services, these are used on almost every single office building around the world, depending on its size. They're very effective at rejecting heat. So what happens is you use these to reject the heat from the building. So all the heat that's picked up from people, computers, machines, lighting, all the solar gain, all of that heat needs to be removed from the building to keep it cool. So that's picked up by a chiller, and it's sent from the condenser up into one of these, which is a cooling tower. And the purpose of this plant item here is to take water in at a certain temperature and put it back into the building at a much lower temperature so that it can pick up more heat again and send it back up to be chucked out of the unit. So let's have a look at some of the components in there. You'll see on the top we've got a fan. So this fan obviously spins, and as it does so, it pulls air out of the unit. Air flows in, fresh air, ambient air here around you, flows in from these panels here, which are just filters. They're called an inlet shield, and just to stop sunlight and dust and bugs, maybe animals, even children getting in there. And so the air comes into this point here and then makes its way up and gets pulled out of the cooling tower at the top here. And on the outside we've got a motor here, and on this example I've just made a simple belt drive system which pulls that fan, but the motor could be mounted inside, or it could be on a gear ratio or something like this. But we're just keeping it very simple on this one, so I put a belt system on there. And actually, let's have a look inside the unit here. So this is a peek inside the unit, and as you can see, we've got some pipes here with some funny looking plastic parts here and here, and a few other little pipes. And let's just change view there. So the condenser water, which is the warm water that's been collected from the building and been sent up by the chiller, that enters through this pipe here and enters into this header, and that warm water is then sprayed out of these spray nozzles. In the real world, the spray nozzles coming down onto the packaging will look a bit like this. So these nozzles here, kind of this, and they're just spraying down across this fill packaging onto this, which is known as the packaging or the fill. In the real world, the packaging will look something like this. And the purpose of this fill is that the water, the condenser water, will run as it's sprayed in really fine particles, and it collects and runs down the sides of these in the thin film. Now the air which is rushing past the other way picks up heat from this, because if you let it just kind of run out, then it's got a small surface area. But if you spread it out and put it across a really thin film across all these packaging sheets, which is made of plastic, then that increases the surface area, and so you're maximizing the area that the air can reach, can touch. And so as it does that, it pulls the heat out of that water. The condenser water will then roll down the side here and drip down and collect down here in the basin, and that warm air will enter through these sides or these panels here, make its way up through these grills of the fill packaging, past this pipe work, up out through the drift eliminators, and then out through the top. As that water pours out of this pipe work here and it sprays and becomes a thin film along this fill packaging here, what we're going to find is that some of the water will evaporate, which takes some of the heat away, but we're going to lose moisture to that as well. So the purpose of this, which is called the fill packaging, it's called the drift eliminator. What happens is the air enters into here. It's being pulled by this fan at the top here, and the air is coming in at a high velocity, and it's impacting, it's hitting against these surfaces. It's going to make these really sharp turns to get out of the system and get to where the fan is trying to put it out through. So as it does this, and it's colliding with the sides, and that's giving the moisture in the air a chance to condense on the sides and then run down. So the more impacts it makes, the more it's condensing that vapor in the air and allowing it to condense and pour away. So we reclaim some of that water which we would otherwise have lost and be sent out to the atmosphere. Down in the basin here, we have got a number of pipes. We'll see the biggest pipe here. It's about a 6-inch pipe, and that is the outlet. So this is the condenser water return, which is going to go back down into the building and down to the condenser of the chiller. Over here we've got the water inlet, and that is connected to a ball valve. So as the water level gets too low, this will allow more water to enter the tower. And keep this filled to a certain level. Over here we've got the overflow. So if, say, this was to have got stuck, something like this, the water would pour in here to fill it up, but there's nowhere for that to go, and you don't want it to fill up and start going through the tower out the sides here. So we've got an overflow here. Just to take some of that flow away. And then the last part here we've got is the drain. So the drain is quite important, because in the water that's entering this tower here, the water contains salts and bacteria and stuff like that, and that will, as this water evaporates, is going to leave behind that salt and the gunk and muck that's contained within the water, and that salt won't evaporate. That will all start to collect up here in the basin, or up on the fill packaging, etc. And so once it reaches a certain level, this will need to drain. So the cooling tower will be told to dump a lot of the water that's in this tower down to drain, while they add fresh water, not through that one, sorry, through this one. They add fresh water to the system, either through here or through the condenser water inlet there. And once that has reached a certain amount of parts per million, the minimum threshold, that drain will close, and it will continue in its cycle of operation. And that's really it for a cooling tower. Well, for this type of induced draft open cooling tower. There's lots of other types of cooling tower, and we'll run through some of those in our other videos.